Hey friends, today we're talking about classifying triangles and angles. Okay, so let's review angles. An angle can be classified by its measure. For example, this guy is less than 90 degrees and he's acute. Look at that little acute angle. This guy's always right. He forms perfect corners. His measure is 90 degrees and you can see his corner right here. A lot of times you will see this in figures to know that it's a right angle. And then we have these obtuse angles. They're the big angles. Their measure is greater than 90, but less than 180, okay? Because 180 is that straight line. So if he gets to that point, he's just considered straight. The one that you might not know yet is the reflex angle. So go ahead and write this down if you need to. The reflex angle is the one that's greater than 180, but less than 360. It kind of forms that elbow-looking shape, okay? So it's the outside of what would be your elbow. This is your reflex, just like if you went to the doctor and he tested your reflexes, okay? So you would see that angle at which he would be looking at on your elbow, okay? Let's look at what it means then for a triangle. To classify your triangle by its angles, you need to look at all three, okay? That's important. An acute triangle has all three of these angles as being smaller than 90 degrees. A right triangle only needs to have one right angle in order for it to be a right triangle. And an obtuse angle only needs one angle that's greater than 90 and less than 180 to be an obtuse triangle. If we wanted to classify it by its sides, we would look at the ones that have all three the same and know that they are equal. So they are equilateral. That means all sides are in equal length. An isosceles triangle has two sides that are the same. And you can see it with these tick marks here. They show you this side length and this side length are the same. And then scalene is what we call a triangle that has no sides that are the exact same. So this side is different than this side and is different than this side. So make sure you've paused the video to write down some of these notes. So let's look at some examples. Classify the following triangles. So you know some information about these. We don't know anything about their side lengths, but let's look at their angles instead. Okay, go ahead and try it and I'll be back in just a second to show you what I did.
So you write it in right now.
So if we classify the following triangles, this one's got a right angle. This one has three acute angles and he's got an obtuse angle. So what does that mean? If that's the case, then he's a right triangle, he's an acute triangle, and he's an obtuse triangle. Okay, let's look at some more examples. Classify this triangle by its angles and by its sides. So I want both of its names. And then down here, go ahead and classify these triangles by its side lengths. Make sure you check your notes carefully, all right? And I'll be back in just a second to show you what I did. Okay, so in this first one, what I did was an acute isosceles triangle. Why? Because all the angles are less than 90 and two of his side lengths are the exact same. If we classify this one by its side lengths, we get this one's also an isosceles because there's two 7s. Which ones down here are also isosceles? Number 5. Number 5 is because it's got two 10s and then the 8. If we have ones that have all equal length, then it's an equilateral. So both 2 and 4 are equilateral. If we look at 3 and 6, none of the side lengths are the same. So they're both scalene. Okay, so how does this information help us? Well, now we're getting into the real meat of geometry, and we need to know about how angles work together. So if we look at all of the angles of a triangle, and maybe we took a piece of paper and we broke all of its angles off, and then we reworked them, they would form a straight line. So the measure of all of the angles of a triangle together equal 180. So if we look at this triangle, x plus y plus z equals 180. So how does that help us? Well, if we're solving for missing pieces, like in this one, we can then set up an equation. X plus 75 plus 60 equals 180. And then we can solve. So we can combine our like terms. Okay, so when I solve, I can combine my like terms, get 135, and take that away from both sides. And since I know the whole triangle equals 180, I take 135 away from it and get that my remaining side is 45. Don't forget to check your work with a calculator. Add up 45 with 75 with 60 and make sure it equals 180. So down here we have a sailboat, and we know that this side length is 20 and this side length is 70. So 20 plus 70 plus our unknown x equals the total triangle, which is 180. So here we have 90 plus x equaling 180. So take 90 away from both sides, and we're left with x equaling 90, which makes sense because this should probably be a right angle if it's a sailboat. Okay, so let's look at some more examples. I want you to try these yourself. Find the value of x in this flag right here shown to the right. You've got 55 degrees here, x here, and some sort of a measurement that you should know. Try it the same thing for number 2, and I'll be back in just a second to show you what I did. Okay, so you should have showed all of your work for me. Make sure that you checked your work with a calculator. Okay, so in the first one, here's what I did. Okay, so I put all of my angles, and this one, remember, is that right angle, so it's 90 degrees, and then I set them equal to 180. When I added 55 with 90, I got 145. If I take then and remove it from both sides to get x by itself, I get 35 degrees. Don't forget to check your work. Down here, I can do something a little fancy if I wanted to, and I could take 2 times 42 plus x equaling 180. And when I do that, I get 84 plus x equaling 180. So take 84 away from both sides, and when you do so, you get 96. So my x is 96 degrees. Don't forget your degree symbol. Okay, so these are the last 3. Go ahead and try these. Show all of your work. If you want to use that fancy trick that I showed you where you just multiply by 2, you can do that. All right, and I will be back in just a second to show you what I did. Okay, so in this one, make sure that you showed your work. You should have this whole triangle equaling 180. So 15 plus 25 plus x. So over here you get 40. And then you're taking 40 away from both sides. And when you do so, you get x equaling 140 degrees. Over here, you have 90 plus 30 plus x equaling 180. So we have 120 plus x equaling 180. Take 120 away from both sides, and you're left with x equaling 60 degrees. Down here, we can do something fancy. There's 3 of them, so it's 3x equaling 180. Divide both sides, by 3, and you get 60 degrees. If all the angles are the same, what do you think this triangle is? Hopefully you said it. It's an equilateral. Correct. Because if all the angles are the same, all their side lengths should also be the same. All right, and that's all I have for you, so I will see you next time.